Now, what do you think if I say stdc out, which stands for displaying things, right? And I print something like hello right there. Do you think this program will ever print hello? Yes, no? No, because although I added function foo to my program, I never took care of making a call to it. Therefore, it's not going to happen. It's like, we call it unreachable code. It's almost like garbage, but it's unavoidable because when you write stuff, you typically create multiple functions and other things and even multiple files. You just think about this function that does something, maybe, I don't know, computes an area of a rectangle, whatever it does, right? And you write it down, and you don't even have a place where to make a call to it, but you already have it ready. So it's not total evil, but it's just unavoidable to have sometimes code in your program which is not really physically reachable at program execution, because perhaps this program is unfinished and later on, like tomorrow, I can come back and say foo right here. You can see that function calls are very simple, like define the function, and to connect to it, to make a call to foo, you can say, you can just use its name, then the parentheses, because this is how your compiler is, that foo is a function, by seeing the parentheses. Nothing else has parentheses, only functions or methods in Java. Functions, by the way, are called methods in Java. And so a good number of C++ programmers actually call their function methods, because that's what happens in the Java world. I usually prefer to differentiate. If I'm working with C and C++ programmers, I prefer function terminology for, for these pieces of executable code. And when I work with Java projects and programmers, I refer to functions as methods, because that's the name of a function in Java. It's called method. And that, again, comes from Java object-oriented, pure object-oriented philosophy, where method is essentially one of the terms largely used in descriptions of object-oriented principles of Java. And that's fine, okay? But remember, function, things such as procedure, function, method, are usually referring to the same thing. Essentially, a little piece that has those curly braces, that has the name, and that can execute some code. Now, in all modern programming languages, for the most part, okay, you typically cannot or don't want to place any executable code outside of a function or method. And so your function or method in Java is the placeholder for the executable code. But you also occasionally create local variables, and that's what's expected. That's your essentially building blocks of your programs, right? So major building blocks of your C program would be functions and local variables, and major building blocks of your Java program would be local variables inside methods, because methods, that's what functions are called in Java. Okay, so we talked about some aspects of local variable, and I think we're gonna get to more, more closer look at local variables when we discuss indirect access to variables. So we're just going to see the way they behave. Interestingly, that we already had a sample which did display memory address. Here's another example which is purely C. This time, this is a C example, and you can see that, again, I will just copy and paste and just replace what I have here on cpp.sh, C++ shell. I'll just replace it with this, and this is C function, C library function. I should mention, perhaps, when I go back here, Okay, I should say that whenever I use cout, I need to include IO stream. Whenever I use cout, I have to use IO stream and include it in my code. When I use printf, like the one that I again copied over from the presentation slide, I need to include cstdio. That's a standard header in C++, and the entire library of system functions of C programming language is available in C++, so that's not a problem. Basically, C is a subset of C++. It's just the way. There are some very, very slight differences, but for most of us, they're completely invisible, that we don't even know that they exist for our entire careers. I mean, the differences between C and C++. But sometimes it's good to know about things when you have some weird bugs or problems to work on. Well, anyway, print right here. Let's run this and see what it does. Okay, so it says x, which is the name of the variable. It's a local variable declared inside function named main. Okay, and it says x is stored at, and it prints something like this, which we're sort of like expecting that those crazy hexadecimal numbers are pretty much used to point to specific physical locations in computer memory. Now, let me switch here because it's easier for me to increase the font. I would like to just take a closer look at this. Print can be a little confusing because what it does is just says, oh, just like that cout object we used in a pure C++ output, C function print, which is a system function that comes from this include header. More about that later on as well. But print says you give me like a template, and I'll use it for output. For the most part, this template is just normal characters, but the percent sign is special. Percent sign says, oh, this is a little placeholder for whatever you provide over here. Okay, so over here I have %x, and over here I have %p. So that's why when I run it, it says x is stored at, and %p is replaced by this %p is replaced by this absolutely crazy value. Like here too, I can increase the font here. You can see that this is just like a really big number. By looking at this number, I can assure you that we are running on 64-bit platform. This particular, whatever machine is running this for us is a 64-bit, because this is a very large number down there, huge number, big number. Okay, so let's discuss what is going on. Over here, we say on the slide is, why does %p format display the memory address in hexadecimal format? Okay, since we're trying to be computer scientists here, okay, and we decided that the concepts of memory are important to us, when looking at individual memory addresses, it's a very common agreement to refer to individual unique locations in memory using hexadecimal numbers, okay? And our book, if you read those pages I posted, it says, it's just the way engineers typically refer to memory addresses. Well, this is a little bit too short. It sounds a little bit more like black magic to me. Like, you just showed me this. It looks crazy. It looks scary, right? And you just tell me this is typically what we do. I might as well just try walking away from this because it's just way too scary and doesn't look very friendly at all. Okay, so what's going on? I think that it deserves a little closer look at what is happening. Okay, so once again, let's bring this crazy thing which we just printed on our screen, and it appears to be the location of variable x in computer memory. Well, at least we knew that x should be someplace in computer memory, and now we found a way. If you look at the source code of this program, we found a way to display that address. Okay, fine, but what about this 0x and whatever comes after it? It's good to talk about this. Let me just make another segment and we will continue.